Hello, welcome to the Zarhus Developers Meetup 3, first part. And what I'll be presenting today is context-based authentication, so identifying host by the environment. And what I have here is something to cheer you up. It's the picture from my ad hoc testing, very early stage, and I consider it a totally normal computing. So about me, my name is Mateusz, and I am a former system software development engineer at Intel. I like to say that I used to develop MDM utility. And currently I'm the junior embedded systems developer at 3MDev, and I'm the member of Zarhus team. And here are some medias that you can check me out. And yeah, let's proceed to the presentation. So location-based authentication. The first thing that comes to your mind when talking about location-based authentication is geofencing. It is the classic mechanism we know from like streaming services where those pesky greedy corporations, these allow you access to the show that are available in the other countries. But there are issues with this technology. First of all, it relies on the data like GPS and cellular information. And not only you have to have dedicated hardware for to just use it, I guess. And another thing is these are easily spoofable. Importantly, the GPS is very spoofable. So that's when the CBA comes in. And let me briefly to introduce you to the concept of CBA. So CBA stands for context-based authentication. And basically, it relies on finding anomalies in some user patterns. It's classically used to authenticate users. And anomalies could be like logging from other device, logging on non-standard time or from different location. Yeah, and that's basically what the classic CBA is about. And we will talk about the different use for CBA, but let me first introduce you to the concept of the RFF, which stands for radio frequency fingerprinting. So basically, no manufacturing process is perfect. And when you produce the Wi-Fi chips, each chip has some is just not perfect. So by those imperfections, we can identify those chips. These are so unique that basically they are like the fingerprints on your fingertip. We can identify each device by some physical signal characteristics it transmits. And yeah, the implementation of CBA I be talking about uses those RFF information to basically identify unique hosts. And it's not about authenticating users, but authenticating device to device. And yeah, this technology, or rather the implementation, was not built in-house. It was delivered to us, but I will talk about it later. But when I first received it, I got a chance to review it. I had two questions. First question was about the probing resolution. So the question was that, can I use the device I want? Doesn't it need to be like some high-end device so the data it fetches have like high resolution? And the answer is yes. The more higher end devices, generally speaking, deliver more detailed information. But we have some mechanisms to work around that, and one of these mechanisms is the machine learning. And machine learning is not necessarily used to compensate for low resolution, but rather to figure out the unique characteristic of the device that performs the sniffing. And based on that, we have some certainty that the data we are receiving are more or less enough resolution or appropriate. And the second question was, why not use stuff like MAC or IP, etc.? And this is quite a simple answer to that question, because those are easily spoofable. That's the first thing. This shouldn't be an issue in the dense environment, for example, in the data centers when you have a lot of devices, and it would be very hard to reproduce that environment remotely. for somebody to access. But in less dense environment, that's always the chance. So that's one thing behind not using it. And the second thing is that those are cryptographic based. So not every device, because the solution I'm talking about mostly targets like low-end devices. These are cryptographic based, so each device have to have like some higher end computing power to process cryptographic operations, while analyzing physical signals is much less computing hungry and can be offloaded to other devices. Yeah, and now I have to introduce you to the CrossCon project. The CrossCon stands for Cross-Platform Open Security Stack for Connected Devices, and it is a project we are collaborating on with various other universities and companies to develop some secure solutions for connected devices. And the main product of the CrossCon is the CrossCon hypervisor. Yeah, and before we discuss Stack, let's talk about CrossCon. So CrossCon is a very lightweight hypervisor that can run both on devices like Raspberry Pi or even on the MCUs, so basically microcontrollers, and I think that's really cool. So during our testing, we had the chance to run it on LPC Espresso 55S69, I believe it was, and RPI4, and the demo I will be presenting today will be running on the RPI4 platform. So yeah, hypervisors. That's basically the stack that will run on a single Raspberry Pi in our demo. So let's start discussing it from the right. On the right, we have a Linux-based VM. It is a custom Builder-based Linux distribution, and we will be running the TLS client and TLS server on two devices. And I will talk about that thing later. But yeah, the first VM to the right is the Builder-based VM to run the TLS applications. The VM to the left is basically OPTI-based VM. It is the trusted execution environment, and it hosts the PKCS11TA. And that application is used to store private keys for the TLS client and TLS server that we will be running. It is the secure environment to store the keys, and we have not have direct access from outside of it. Yeah. The second VM to the left, it's also OptiOS-based VM, and it's running the CBATA. It is the custom application that will basically gather the CSI, which stands for Channel State Information Data. So it's the information about the physical capabilities of the signal and sends those to the another entity I will talk about on the next slide. And yeah, it will basically do that. Yeah. And the last VM, the further to the left, is just yet another Linux-based VM, and it is used to maybe differently. Let me say differently. It's the OptiVM that will fetch the CSI information uses the Linux networking stack because it was hard to implement the driver for custom firmware Wi-Fi chips, and it had to be implemented in the Linux because there were some issues in OptiOS, but we are not responsible for it, so I cannot give details why that was. So what you are seeing here is the more refined hardware setup I presented you at the, I believe it was second slide. Yeah, and maybe let's start from discussing the demo I will be presenting. So the demo is basically the TLS based message server. It's just a server and a client, and they both exchange a single message over TCP socket. And what it's supposed to showcase is using the context-based authentication in some practical solutions as a second factor authentication. So first factor is done via TLS handshake, And once the TLS connection is opened, or rather TCP socket over TLS is established, the server will be verifying the client's authenticity based on the context-based authentication. And if the second factor authentication succeeds, then the message will go through from both ends. Yeah, and maybe let's quickly discuss the setup you're seeing. So this is my work laptop, and on the top of it you can see two Raspberry Pi 4 8GB version. And each of the Raspberry Pis is running the stack I showcased you in the previous slide. And they are connected via Ethernet cables to my PC. And also they are getting power from the PC. Yes, I am amazed too that it worked, but it worked. And yet another thing is the UART adapters, because we don't want to rely on visual information, rather we just use the console. Yeah, and that's basically it. Let me also discuss the role that laptop is happening, that is being, what's the laptop doing? So first of all, it serves as a router, and basically you host the DHCP so that both Pis can communicate. And it's a common network between the Pis and the computer. The second thing it does, it serves as a common certificate authenticity. Sorry. Yeah, it basically is a common thing that gives the certificates, or other provisions, both the Pis. And yeah, and the final role it performs is it hosts the machine language server I talked about previously. The machine language server is used to, the client will send enrollment to the machine language server, basically gathering the context-based information around it, the contextual data, as an enrollment. So the machine language model will install some initial fingerprint of the client, and then it will be used for verification. So if the client proves that by sending the contextual information to the machine language model, once again, that its position or origin didn't change, then the machine language model shall grant it the signature it can use to verify against the TLS server. Yeah, so that's basically it, and I think we can proceed to the demo. Yeah, exactly. So let me switch tabs to, I believe, yeah, I don't have it open, so let me quickly open it. Yeah, and I think you should be seeing the video. So what you are seeing is the setup I discussed in the office space, because this is where we will be performing the enrollment and the initial verification. Let me grab a chair so I can sit and show you the videos. And yeah, unfortunately, I cannot show it to you live because, as you can see, the setup is barely mobile, and I don't really want to risk it breaking. So we will have to just do with the pre-recorded videos I have. Yeah, so initial enrollment, the office space. And now we'll switch to the command line. So on the left, I believe you can see the output from the TLS client, and on the right from the server. Oh, it will become clear later. But what we are doing here now is basically triggering U-boot to boot the Crosscon hypervisor, because unfortunately it isn't that production ready, and there are still some tricks that have to be done to launch it. And yeah, you can see that the Crosscon hypervisor is starting, and that the Linux build root VMs are already producing output. And what I'm doing here is basically booting both devices that you saw and logging in. And I believe in this video we'll also request the IP addresses from the computer which serves as a router. And yeah, that's basically what I'm doing. Let me fast forward a bit. And yeah, you can see that we successfully obtained the IP address from the computer. Yeah. So let's go to the next video. And what I'm doing here is logging via SSH. Why? Because there's a known bug that the serial can hang after a while. So that's one inconvenience we have to work around. And yeah, I'm copying the IP addresses and I'll be pasting them into the simple build system, because not exactly for building, but it is one of the steps that is being done, but we have to provision the pies with the certificates. And it is basically what I'm doing. The application tells client and tells server gets recompiled, flashed to the pies over SCP, and also the certificates are being generated and both of the pies are being provisioned. Yeah, and it is exactly what's happening and it succeeded. Yeah, so let me switch back to the terminal. And on the top, on the window at the bottom, you can see that I'm starting the machine language model. And it says that it's listening. And on the left side, I'm starting the server. And on the right side, I'm starting the client and connecting to the server by its IP. Yeah. So now enrollment happens. So you can see on the server side that there's some activity happening already. And I believe, yeah, and now just to fast forward, because it takes like a minute and a half to gather those informations, you can see that we successfully enrolled. The server outputted some information, and the first factor succeeded between the both nodes. So now the TCP socket is opened, and the server will have to be verified if it changed its location. Yeah, and you can see once again the office space, and just to prove that I'm not like I don't know, that I'm not faking it. That's the word for I was searching for. Yeah, so the enrollment was done in the office space. And there's also a close-up on the pie, because when it fetches the CSI information, it just displays some LED pattern. Yeah, and I think that we'll be seeing exactly activity on the machine language model. We get the signature, and we can see on the server side on the right that the authentication succeeded. And the classic use case would normally end up here, but I had to modify the code to do some sanity checks. And the modification was to do the verification 3 times in total, because for the second verification, I have to switch the context, so location, to prove that when I switch location, the verification is no longer possible. Yeah, so basically what I'm doing here is launching yet another verification, and it's taking place. And I believe the next video, no, not this one yet, this proves that when I switch location, the verification was no longer successful. It was some mockup we did to showcase, I mean, not exactly showcase, it's just how implementation is done. And on the server side, you can see that the verification failed. Yeah, and where I went to the office kitchen when it's basically on the other side of the building. And why there? Because that's where my Wi-Fi bars dropped out to 0, and I knew that I shouldn't be getting any contextual information from the devices in the office space. So yeah, the second verification failed. And now I believe we are proceeding to the final verification that is being done in the office space once again. Yeah. So I just type here to perform it. And on this video, we should see that it succeeded or not. Yeah, so as you can see, I went back to the office space and the verification was successful once again, which proves that context-based authentication example is indeed working. Yeah, and sorry, wrong thing. Yeah, this is the video I was looking for. Yeah, and it's once again Office Space, and it succeeded. And as a final confirmation, the message I was talking about. So the demo is really basic, but its aim is to showcase the authentication, not do fancy stuff, and just to prove to you how the what's the current state of the solution. And I mean that it's very, very early stage, basically just proof of concept. You've got a beautiful segmentation field at the end, but we can see that both server and clients receive the information, sorry, the message. Yeah, and that's basic. That's some logs I just have in this directory, and that's basically it for the demo. I'm really sorry that I couldn't show it to you live, but as I said, it's barely mobile. And yeah, if you want to learn more, I left some references. You can take a look. References to the what is the Crosscon project, the build system if you want to reproduce the demo, although I don't know if I recommend it because it will take like a day, but you can, so if you want to. And yeah, that's basically it from my presentation. And I think that we have 2 minutes left, I believe. So time for questions.
Yeah, I was just wondering, like you're saying, this is that to build that is one day, but is there any publicly available image that could reproduce that, or someone who wants to reproduce have to do everything from scratch using some procedures from the links?
Sure. So there is the README prepared that showcases how to reproduce the demo I just did, although not the part that with 3x verification. But yeah, the README is linked in this presentation, and I believe the management will find a way to give it to you.
Mm-hmm.
And unfortunately, there is no public image that can be easily downloaded. Yeah, because it's basically complex process right now, whole provisioning, etc. And you have to have the Pi 8 GB version. Yeah, it's very early stage of development.
Mm-hmm. Okay, so I guess like one improvements which it needs is like a way easier provisioning.
Yeah, exactly. And the build system could also be made much more user friendly, in my
Mm-hmm.
opinion.
Mm-hmm. Okay, cool demo. Cool demo. Like, what's your kind of um, like what can go wrong?
What do you mean exactly?
What can go wrong in terms of like while leveraging this kind of methods? Like, what are the drawbacks of leveraging those context-based authentication methods?
You know, I don't necessarily think of drawbacks right there, but it's definitely makes the solution more complex. And I think the scalability might also be the issue right there, because as I said in the beginning, we are targeting like more IoT based stuff, and there isn't really, for Crosscon at least, solutions for like more mature platform like x86 and so on.
Mm-hmm.
Yeah. So I think my answer would be to maturity of this solution and complexity.
Okay. Okay. Thank you very much.
Thank you.